Okay, in this video I'm going to look at the tangent function. If you can remember, the tangent function is equal to the sine over the cosine. So there's a very close relationship between the sine and the cosine and the tangent graph. Certain properties that happen in the sine and the cosine affect how the tangent graph will appear. Let's first look at the cosine. So I've drawn the cosine graph here. I've just sketched it in. If you notice, cosine is in the denominator, so whenever cosine would be equal to 0, that would make this fraction undefined, which would give the tangent graph a vertical asymptote there. So if you look, everywhere that the cosine graph crosses the x-axis at multiples of pi over 2, negative pi over 2, negative 3 pi over 2, pi over 2, 3 pi over 2, and you keep going on, every time that happens, you have a vertical asymptote there. So I just sketch in the vertical asymptotes at those points. Relating to the sine function, whenever sine is equal to 0, that means that this fraction would be equal to 0, so tangent would be equal to 0. So wherever the sine graph crosses the x-axis, that's where tangent will be equal to 0. So sine starts here, it's 0. At pi again, it'll be 0 again. At 2 pi, it'll be 0 again. So we need to see what happens in between these vertical asymptotes. Okay, so I've sketched in the tangent function now. Now, something that's interesting here, if you remember, sine and cosine of pi over 4 are both square root of 3 over 2. So square root of 3 over 2 divided by square root of 3 over 2, that would make that when the angle is pi over 4, that makes tangent equal to 1. At negative pi over 4, sine would be negative, so it would be negative square root of 2 over 2. Cosine would be a positive square root of 2 over 2. So the negative divided by a positive will give you a negative 1. So the graph comes from the bottom on this, near this asymptote, goes through negative 1, 0 where the sine is equal to 0, pi over 4 it's equal to 1 where sine and cosine are equal to each other. So then the graph goes up that way. And the same thing here. Halfway between pi over 2 and pi, it'll be negative 1. Halfway between pi and 3 pi over 2, it'll be positive 1. So again, it has the vertical asymptote. It comes from the bottom, crosses at negative 1, crosses the x-axis at 0, where sine was equal to 0, crosses again at 1, where sine and cosine are equal to each other, and then it continues up. So you can see from the graph that the length of the x distance between where the one asymptote is and the next asymptote, then the graph just repeats itself. So this distance is the period. So this is 1 cycle, 2 cycles, 3 cycles, etc. So this distance from negative pi over 2 to pi over 2 means that the period of the tangent graph is pi radians. So every pi radians, it will repeat itself. Tangent has some of the similar properties as sine and cosine. It still has the same values. These things do the same thing to the function. A stretches the tangent graph vertically. So instead of it going through pi over 4, 1, if you multiplied it by 2, then it would go pi over 4, 2. So it would stretch it vertically. B, this thing, is equal to the period of the pi, is pi divided by the period. Notice this is different from sine and cosine. The tangent graph the period is pi, so we only use pi here. So B is equal to pi over the period, or the period of the graph is equal to pi over B. C is a phase displacement, moves the graph left and right, and D moves the graph up and down. Some other things, the period of the tangent graph, I already mentioned a couple of times, is pi. The domain is every theta except for pi over 2 plus or minus multiples of pi. So if I have, remember, that's where the cosine graph crosses the x-axis. So where cosine is equal to 0 is at pi over 2 and multiples of pi after that. And where k is an integer. So you could go to the left and to the right whenever it's equal to pi over 2 plus some multiple of pi, that value is undefined in the domain. And the range, it comes from negative infinity and goes to positive infinity. So the range of the tangent graph is from negative infinity to infinity.